Hello all, it's been some time. We're going to go into a quick discussion of basic recursion. So, what is recursion? Well, basically, it's a method by which we can reuse the same method and go through sort of a branching path to get an answer out, um, as opposed to some more sequential programming where we have some loop or where we have some if statements that just sort of execute in an easily readable manner. Recursion um, is when we have a function or a method that calls itself during its execution. Um, so you can imagine something like this. If I were to do a standard program without recursion, a non-recursive program, to add up the numbers from, say, uh, 1 to 10, or from 10 down to 1, I might do the following. I'd make a sum, set it to 0, and I'd say for I equals 1, I is less than or equal to 10, I plus plus, and fix that. And so we could say sum plus equals I. And then we'll print the sum out. So this prints the sum of the numbers 1 to 10, which is 55. And, we should be able to do many things with standard programming, non-recursive programming. But when we talk about recursion, we could do a lot of this stuff recursively as well. Now, let's see an example of what this might look like. This is probably the most basic program you can have that actually does something recursively. So let's think about this. We'll do a public static int sum. And we'll make a public static int sum method, and we have a couple things we have to pay attention to with recursion. And sum is also going to take in some integer that we're adding up to. We'll call it target. So to start out, we'll say that we have well, we want to add up only until we reach 0. So the two things we need in recursion are sort of a return statement, and before that we need some sort of base case. What do I mean by base case? I mean something that lets us know when to terminate. So we need to figure out our base case when we want to stop adding numbers, and we want to figure out otherwise what we're going to be doing, how we add these numbers. Well, how we add the numbers is going to be sort of an interesting situation. So let's say we start with a target of 10. Well, what do I have to add to that? I have to add, well, add the sum of 10 minus 1, right? The sum from 10 minus 1 down to 0. So we have 10, and we want to add to it the 9 plus the 8 plus the 7 plus the 6 plus the 5 plus the 4 plus 3 plus 2 plus 1. And so what we can see here is that we can have this whole idea where we say, okay, well, I want to take 10, and I want to add to it this bunch of stuff. And what is that bunch of stuff? Well, it's really just 9 plus this bunch of stuff, which is really 8 plus this bunch of stuff, which is really 7 plus this bunch of stuff, and you can see where I'm going here, which is really 6 plus all of this, which is really 5 plus all of this, which is really 4 plus this stuff, which is really 3 plus these two numbers, which is really 2 plus this last little bit. And so what is the base case? Well, the base case is what's in that last set of parentheses here. It's how I know when to stop, when there's nothing else I could possibly add to it aside from 0 to get back the sum of it and the numbers below it. Now, this doesn't necessarily work if we're summing below 0, if we go into negative numbers, if we go into negative values, because what's our base case then? When do we stop? So we need a defined base case, a defined idea of when we're going to stop in order to have a successful recursive method. Okay, so what does this look like? Well, we need to know that if my target is equal to 1, well, what's the sum of 1 down to 0? I'll just return 1. And then I look at the other stuff I want to do. Typically, if I don't have 1, I want to say return the target, whatever it is, say 2, plus the sum of target minus 1. Okay, so what is this saying? It's saying I take the number I'm looking for, the 10, and I add to it the sum of everything below it. The sum of 9, which is really the sum of 8 plus all this, which is really the sum of 7 plus all this, which is really the sum of 6 plus all this, etc., etc., etc. So going through, the question is, does this perform the same function? Well, how does the return call work? Well, in general, I have this thing called a stack, and every next call to this function sum puts a new instruction set on top of the stack. And then I have to go and I have to add a new instruction set until suddenly I reach the end. I don't add any more instruction sets, meaning I'm not calling sum anymore. I just return some normal number, and I finish out. So before we run this, let's look at how this would actually function. So I have 10. So I plug in, let's say I call sum 10. Does the following. It says, okay, well, is 10 equal to 1? No. So I look at this return statement. Return 10 plus whatever I get back from this statement. So I do 10 plus something, sum 9. Well, what is sum 9? Now I need to go into that and resolve that before I can actually do my final addition. Well, sum 9 is 9 plus sum 8. And what is sum 8? Well, sum 8 is just 8 plus sum 7. And what's that? Well, obviously it's going to be 7 sum 6. And we continue on until we get down to 2 plus sum of 1, which is just 1. And then I do my chain of addition. I say 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9, and that goes into this value, which is 10. So I go, once I finally resolve, I have something to return. I reach the return part, and I actually execute this statement. Until this part resolves, my return statement doesn't execute. Only after I know what this value is do I get to my return statement. Only after I know what this value is do I get to my return statement. Only after I know what this value is, and I go until I do know what a value is at my base case, and then I sum everything up. So let's prove that this works. I'm going to call this method. Well, what am I going to do? I'm going to call sum on, let's say, 10. Let's see if I get a 55. I do. Let's do sum of 100. 50, 50. Let's see how fast this recursive method goes. Let's say I call sum of 1,000. It's a little slower than it should be. Sum of 10,000. So you can see that this would work. So now I have an issue. What is my issue? I believe I have a Stack Overflow error. I've added too many instructions to my stack. And this is what can happen if you have an infinite recursion or you have too many method calls going on top of this sort of memory structure that determines what order instructions go in. So ultimately, you can get this error here, Stack Overflow error. There's a great help website called Stack Overflow, been around for a decade or more. That's been more than that for sure. That's been really, that's based. The name is based on this idea of using up your available instruction space. Okay, so sum 1,000. Let's change this to maybe multiply. Instead of multiply, it turns out the name of continuous multiplication of every number below is called factorial. So we'll call it factorial. And we'll say, what's the factorial of 10? Well, now I need to change this to factorial. Now I need to see, well, target equals 1. That's fine. So now we say factorial. By the way, to prevent people from entering an incorrect number, we need to say that it should be less than or equal to 1. But let's see what we get. So are we doing plus? No, we're doing multiplication. So let's run this. 10 factorial is some huge number. Let's go smaller. Let's say what's 2 factorial. Should be 2. Good. Because 2 times 1 is 2. 3 factorial should be 6. 3 times 2 times 1 is 6. 4 factorial, 24. 5 factorial, 120. So you see factorial grows much faster. Obviously, it's multiplication. But this idea works the same whether it's a plus or a multiplication. We're still getting the answer out of using the method within itself, and that's called recursion. Finally, well, let's see. How could I print all of these numbers in one direction or another? Well, if I want to print these numbers out, I can print them out by printing out the target. And notice I'm counting down. How would I count up? Let's see. Okay, well, that's an exercise for you. See if there's a way you can figure out how to count up. In general, it just has to do with rearranging a few things here. I'm going to end the video here and keep programming. Try out a few things. Codingbat.com has a bunch of cool recursion exercises. So try it out, practice it. You'll get good at it, as with anything. Have a good day.